Hi, good morning. We still got something to teach. Then we will review solve some problems maybe occur in the final exam. Okay. Last time we have discussed and explained the fundamental theorem of calculus, part one. If f is a function which is continuous on the bounded closed interval AB, and define a function g to be the definite integral of the function f from a to x, where x between a and b, then this function is differentiable on this interval if at the end point we consider one-sided derivative, or otherwise we say this function is differentiable inside or interior to this interval, therefore differentiable on the open interval AB. Because differentiable means whose derivative exists. So g prime x can, if g is defined in terms of this definite integral, here we keep the upper limit as independent variable. Then g prime x equals the integrand, the value of this integrand at this number. G prime x equals f of x. Okay, this is part one. So another meaning of this one can be expressed by if f is continuous on this closed and bounded interval, then the lowercase f has an antiderivative, namely, in fact, g. If f is continuous on this bounded closed interval, then of course this function is continuous on a subinterval from a to x. So this definite integral exists. Exists means the value is a real number. So the lowercase g defined by this expression is a function, a real valued function of one real variable. Okay. Because g prime x equals fx, f is the derivative of g, right? F is the derivative of g. So we say g is an anti derivative of f. Okay. So continuity implies existence of antiderivative. Can be this is an antiderivative of lowercase f. 好，用普通话，用中文。如果 f 在 AB 上连续，那么 f 一定是某个函数的导数。哪个函数呢？还可以写出一个给你看，就是这个函数。用定积分定出来的。我们把积分上限呢当成变数，会发现呢，这个函数对 x 的导数就是把被积分函数作用在积分上限的值，这样。所以 g prime 等于 f， 表示 f 是 g 的g 的导数或导函数。既然 f 是 g 的导数，那 g 就称为 f 的反导数 （antiderivative）。Therefore, fundamental theorem of calculus part 1 ensure that under this condition, f has an antiderivative. In fact, we can write out, yes, this is an antiderivative of f. Okay. Part 2. Okay, we have shown this one. In fact, if f is continuous on some closed interval AB, we define lowercase g to be from the definite integral of the function f from a to x. So g of x stands for, if f is positive, then g of x is the area of this region. What is g prime? Okay, this is the area of this region. G prime means the rate of change of this area with respect to x. G prime means the rate of change of this area with respect to x. Okay, rate of change. So if x has an increment h here, then the area has this increment. This one over this one means rate of change. Okay, this one equals the base times the height. The height almost the value of this function at this number x. Maybe this one is smaller than this, but if h is small enough, by continuity of f, this height and this height almost the same. So g prime means this one, we call this one delta g over delta x. Delta g is the base times the height. The height almost the y-coordinate of this point. And delta x is h. So we have this one. In fact, as I mentioned last time, in elementary school, we know the area of a rectangle is base times height. Base times height. Here means the fundamental theorem of calculus is area over base, so obtain the height. 好，就像我上次告诉你，也提醒过你，你看这个 G prime，G 是代表从 A 到 X 这块区域的面积 ，G prime 就是这个面积对 X 的变化率相对于它的变化率。什么叫变化率呢？就看看当 X 有个增量小 h 的时候，这个面积增加多少？这个面积大约是就是底乘上这个高。 这个高呢，应该不在最高也不是最低的地方，某个地方。不过当 h 很小的时候，根据连续性，几乎都跟它一样。所以说，当 x 有个增量的时候，这就是 x 的增量。那 g 的增量呢，就是这块面积，也是相当于这个矩形的面积底乘以高，这个高几乎是它了，底乘以高。 因此，小学有学过，矩形的面积是底乘以高。那微积分基本定理是告诉你它，这个面积除以底就变成了高，这样子啊，这个微积分基本定理。So after having learned limits, we can discuss more. Okay, this is fundamental theorem text part 1. Okay, next, let's see the part 2. Again, if f is continuous on the closed interval AB, then the definite integral of this function f from a to b equals, capital F of b minus f of a. What is capital F? F is any antiderivative of f. Any. Sometimes we say any or every does not mean the existence of f, capital F. For example, in some classroom, in some classroom, all students has 3 hats. Or any student inside that classroom has 3 hats. If the classroom is empty, this sentence is true. Okay. Got it? If it is not true, means you can find some students in that classroom without having 3 hats. But empty class, the classroom is empty. So each student in that empty class has 3 hats. That is correct. This is a logical statement. Okay, the logic. So any does not mean that the existence. But part 1, under this condition, part 1 already give you a concrete example. So this part 1 tells us the existence of antiderivative of the continuous function f. The function continuous on bounded and closed interval. B